Hello, good day to all of you. In our previous classes, we learned about scalar quantities and vector quantities. This class, we're going to learn about mass and weight and the difference between them, and we learn the concept of gravity and how does it affect the mass and the weight. So without too much talking, let's dive right into it. Learning objectives is to define the weight, mass, and gravity, being able to drive the definition of mass, weight, and gravity, and to explain the difference between mass and weight, and to calculate the weight of an object. By the end of this class, you'll be able to do, inshallah, these all learning objectives. The definition of a mass is the amount of substance, particles or atoms or molecules that are found in that particular object, and mass does not change even if you go to another planet. Mass is not affected by the amount of gravity, it's the amount of particles. Wherever you go, the mass is still the same of an object. Even if you go to another planet or a different planet with a different gravitational field strength, then the mass never changes, but the weight changes. The unit for mass is kilogram, gram, and other stuff. The SI unit is kilogram. You can derive from it as many units as we have learned before. Weight, this is the force of gravitational field acting on an object. The amount of gravity pulling that object towards the center of the earth is the weight. Of course, since it's affected by gravity, so it changes according to the planet that it's in, right? The gravity on the earth is different from the gravity on the moon. So the weight on the earth is different, of course, from the weight on the moon, because it's affected by the amount of gravitational field strength. And the unit for measuring it is the Newton, and the symbol is N. So there are major differences between mass and between mass and weight. First difference is that the mass is the amount of substance in an object, and weight is the amount of gravitational field acting on that object. Another difference is that mass doesn't change, while weight changes according to the gravitational field strength. And the unit for measuring mass is kilogram, and the unit for measuring weight is the Newton, because it's a force, of course, because it's affected by the pull of the earth. Another major difference is that mass is a scalar quantity, because it has only magnitude without a direction, but weight is a vector quantity because it acts downwards toward the center of the earth, so it needs a direction. So weight is what is vector quantity. If you haven't watched the video about the scalar and vector, you could find it in my channel. Please go and visit it. What is the difference between mass and weight? Mass is the amount of substance that an object has, but weight is the force acting on that object. That's what we just learned. All right, the relationship between mass and weight. What is the relationship between mass and weight? If the mass increases, the weight will also increase, and vice versa. We say that they are directly proportional. If one of them increases, the other increases as well. If one of them decreases, the other one decreases at the same time. Calculating weight is the mass times gravitational field strength. What do we mean by gravitational field strength? Gravitational field strength is the amount of gravity on that particular object has on us. For example, the gravitational field strength of the earth, the amount of gravity caused by the earth on objects. On earth, it is found that G is equal to 9.8 Newton per kilogram. For every kilogram, the earth pulls it with a force of 9.8 Newton, or it has a weight of 9.8 kilometer. So the gravitational field strength is 9.8 Newton for every kilogram on earth. You have to put this in mind. Memorize it and keep it. In a formula triangle, we can put it in a formula triangle. So if we are given the mass and the gravitational field strength, we can find the weight. If we are given the weight and mass, we can find the gravitational field strength, and so on. We can derive from it as many equations as we can. So that's in the equation. W is equal to M times G. W, if we cover the W, we get M times G. If we want the G, we get W over M, and if we want the M, it's W over G, which is weight over gravitational field strength. Calculate the weight of a 10 kilogram box of apples. 10 kilogram box of an apples. The mass is what? 10 kilogram. The mass is 10 kilogram, and the gravitational field, we said, is 9.8 Newton per kilogram. So using W is equal to M times G, that means W is equal to 10 times 9.8, and weight is equal to 98 Newton. As simple as that. Just multiplying the mass times gravitational field strength, you get 98 Newton. So the weight of a 10 kilogram apples on Earth is 98.98 Newton. But of course it may vary if we take it to a different planet, because the gravitational field strength will be different, right? Moving on. Calculate the weight of an astronaut on the moon who has a mass of 70 kilogram. I always tend to underline the important numbers. That's the mass. And the gravitational field strength on the moon is 1.6 Newton. We know that W is equal to M times G. So let's find out. We use the formula W is equal to M times G. M, of course, we get it 70 kilogram, and the gravitational field strength is 1.6 kilogram. So using W is equal to M times G, W is equal to 70, the mass, times 1.6, and that's equal to 112 Newton. Nothing is simpler than this. Moving on. Calculate the weight of a moon buggy with a mass of 250 gram and a gravitational field strength on the moon is 1.6 Newton per kilogram, and on the Earth is 9.6 Newton per kilogram. On the moon, the weight on the moon, we get the mass, we get the gravitational field strength, it's 1.6, multiply them by each other, 250 times 1.6, it's 400 Newton, and on Earth, the mass is 250, and the gravitational field, here it's 9.8 Newton per kilogram, and W is equal to M times G. 250 times 9.8 is equal to 2,450. That will be all for mass and weight. If you got any question, please write them in the comments below, and I will be answering them as soon as I can. Thank you very much for watching, and I wish if you could subscribe to my channel and give a thumb up, so that you encourage me to do more videos in physics. Thank you very much for watching.